Now we look at a form of coding which is basically generalized for lossless data compression coding, average coding. Now this form of coding is meant to map M to S, where M is B dash power L dash is mapped to B power L, where B dash is equal to C1 times B and L dash is equal to C0 times L. In other words, L dash is greater than L and B dash is greater than B by an integer factor C1 and C0. Now this is also based on weights only, as we had seen earlier. So this is the basic definition. We must remember that M and S can be anything. Now B dash can be a string, or in the context of a picture or something or video it can be a frame, or it can be in the context of audio a sequence of frequencies occurring at a particular moment in time with their corresponding amplitudes as well, either taken separately or together. So it can be used for anything. It is a very general purpose, this thing. So what we do is, now first we draw a rough table here. I am not drawing the entire table. So for M, forget some of these immediate lines. We don't know how many there are, so we just take it that this is 0, this is 1, this is 2, and this will be L dash minus 1. This is for M, B dash power L. So this will be 0, 1, 2, and so on up to B dash minus 1. So you have B dash column and a B dash rows and L dash columns. You have this box here. To each of these boxes now a weight is assigned. That is for M, which we know, right? So if we the weights for that will be as follows. Just remember this diagram, that for each of these you have that. Okay. Now the weights assigned to this will be as follows. Let the weight assigned for the mth row and jth column be W dash M comma N. Okay. That will be nothing but M into B dash whole power N. The weight assigned to each of those Now, in addition, if we wish to, we can associate with each of those cells in that larger table also F frequency f dash of n comma n. That is, if you have a set of strings or a sequence of strings or a sequence of frames or whatever picture, for each of those locations in each corresponding place, how many times that particular value occurs, that can also be f of n comma n, not parallel. You can do it f n comma n frequency. Okay. Now we draw a similar table for s also, which is b power n. Now it will be similar only. So instead here it will be a smaller table. This will be 0, 1 up to b minus 1 also. Now what we have to do, remember now, is we have to assign to the smaller table weights drawn from the larger table. So how do we go about doing that? So we use the mean. What we do is we construct a square. Now from the larger one, we construct we pick the cells of exactly C0 columns and C1 rows, starting from the rightmost. Fine. So the weights will be like this. Drawn from that table, the larger weights will be like this. This will be, if you want to assign a weight to the wi comma j, be the weight assigned to the smaller table. If you want to assign this weight I comma ith row jth column corresponding to s b power l, we take first any ith jth block consisting of C0 columns and C1 rows from the larger table. The weights there will be these. This will be I C1 b dash power j C0 and so on up to I plus C1 minus 1 C1 b power j C0. Okay, like that you can fill up the table here. The last row will be I C1 b dash power 2 C0 minus 1, then again it will be I plus C1 minus 1 b dash. This weight will be I plus C1 minus 1 b dash power 2 C0 minus 1. So that will be the weight here. So like this you will have a series of sequence of weights. Now to fill up the table for the smaller table for S b power l, what we have to do is the weights formed here will be nothing but a weight chosen from one of each of the weight from each column. So the simplest case where we do not have a frequency associated with the table along with the weight for with each of these weights, what we can do is the smallest weight will be sum of this column, the largest weight will be the sum of all the columns at the top, and all intermediate weights, in all there will be C1 into C0 weights. We can just sum them up and take either the arithmetic mean or the geometric mean or the harmonic mean and plot that as a value for the smaller table at the lower weight, as the lower weight. Like that for each of these, for the larger one you keep taking columns like that and move from left to right or right to left. If now you don't have frequencies associated in addition with these waves, if you do have frequencies, you can multiply it with the frequencies and take the average weighted mean with respect to the frequencies as well. Or if you do not have the frequencies, in the case of the arithmetic coding, if you do not have the frequencies, you can just take the mean of this. That is also not too bad actually. So if in the absence of frequencies, the weight to be assigned wi comma j corresponding to ith row jth column in the smaller table for b power l will be this. This whole value whole divided by C0 into C1 in the absence of frequencies. If you have some Fm comma n as a frequency for this, right? So Fi comma j, based on that, you can multiply the frequencies and take the summation of those frequencies and put them here as well. That is also possible. So this is a generalized average coding. So you can, for the smaller s, you will have to put in those weights, and then given the value of any value of n, using those weights you can code the number, and the value that is being coded will lie between two successive values that will in turn serve as a new value for m. You can extend it to make it integers and do whatever needs to be done. So like that you have to repeatedly code it until the entire frame is coded or within the frame, and similarly all the frames are also coded in a similar fashion, or all the strings are also coded in a similar fashion, or all those frequencies